You can have a lateral, either way. So this combination of lateral load, okay, vertical load and moment, you can represent about any line, any axis you decide. Okay, suppose it is acting here, you can represent it by a vertical load, okay, acting at an eccentricity from here without any moment. You can think it like this, that this action load is acting at an eccentricity. Okay. You can also think it that it is acting at any distance here, E dash, with this force as well as some moment. Let us say this was M, so this is M dash. Can you calculate M dash? How much will be M dash? M plus P dash. Will it be M plus P dash? Equivalent of this. P dash. So if I take E dash here, so it will become more. The effect on the column has to remain same. Okay. So whatever effect this P and M is causing, this P alone is causing the same effect. Same effect has to be derived from here. So what will be M dash? M minus D dash. Okay. So like that you can take it at any axis. All are equivalent. It's up to you where you want to represent this M. Okay. So it's up to you. All are equivalent. Now which axis I should take? I can take anywhere. So what comes to your mind what precaution you need in taking the axis? First of all, when you are analyzing the structure, then you should know where the designer will be using it. Okay, if you give P and M, just P and M, and don't tell anything that where this P and M is acting. Okay, designer can take it here, designer can take it here, designer can take here or any other axis. Will you get the same design? Because the effect will be different. Same P and M applied at different axis will give you different effects. So the designer and analyst both should be clear that about which axis we are talking about. So first condition of that axis is you can take any axis theoretically, but designer and analyst both should have this understanding that where this axis is taken. Okay, that is one condition. Secondly, that axis should not change, okay, with value of P and M. It should remain same. Okay, suppose my analysis gives higher M, axis should remain same, axis should not change, axis should remain same. Okay, and it should be known before analysis. Otherwise, I have to first conduct my analysis and then only I will come to know. So it should be known before analysis. Which axis you think are known before analysis? One can be centroidal axis, other can be this axis or this axis. These are known before analysis. Okay, so you can take any of these axes theoretically. Now question is, can we take neutral axis as the axis which will be or which may be at the center or may be different? So here compression is this side. Usually it is on compression side. So let's say this is the axis. If I take neutral axis, any problem? I can take any axis. I can take neutral axis also. Do you see any problem if I take it as neutral axis?
At neutral axis, that C and P both are equal.
Yes.
P value is 0.
P value is 0 only if it is subjected to pure moment. But In reality, this is C, this is T, and C minus T is equal to P. So neutral axis will take a position in such a way that C minus T is equal to P. So if I take neutral axis as the axis, reference axis, we have to choose any reference axis. I can take neutral axis also as the reference axis. Is there any problem? You see. If I take neutral axis as the axis, is there any problem? Why?
सर आई थिंक जिस एक्सिस के अबाउट आपकी डिमांड आ रही है उसी एक्सिस
नहीं, डिमांड वाले से भी बोलेंगे कि आप एनालिस्ट से भी बोलेंगे कि आप भी न्यूट्रल एक्सिस के अबाउट लो.
नहीं.
We will ask him also to take the moment. Only thing is the condition I told you that both should consider same axis. If both are not considering same axis, then there is problem. Or if you know that analyst has taken about this axis, you should be able to convert it. Then you have to convert it. Okay. So both the demand and the capacity should be about same axis. If those are not about the same axis, then there will be discrepancy in the result. Because the moment value changes, moment value does not remain same about different axes. So if I take neutral axis, is there any problem?
Sir,
Yes.
neutral axis हर बार change हो जाएगा.
First of all, it is not known to the analyst. Analyst has to first do the section analysis to find out neutral axis. Okay. So what you are doing, you are doing that hands-on training in software. Okay. So there you have to assign the member. So you have to assign the member at neutral axis in that case, not at the centroidal axis. You have to assign it at the neutral axis. So neutral axis should be known. Before making computer model, you should know the neutral axis. Okay, then only you can calculate moments at the neutral axis. Okay, so that is not known to the analyst. When you are just making the model, neutral axis is not known. In fact, you don't know even the bending moment. So you don't know the neutral axis. Even if you consider that, okay, I will calculate neutral axis. Neutral axis is varying. Okay, if let us say a column is subjected to moments, let us say like this, then what will be the bending moment diagram, and it is subjected to T also. At the two ends, M1 and M2 are acting like this. Okay, so it is in double curvature. So the bending moment diagram will be like this. On tension side I am plotting, so this is tension, here this is tension. This is M1, this is M2. Okay, so you can see that the bending moment is varying along the length. If bending moment is varying, what will happen to the neutral axis? Will it remain at the same place? So neutral axis will be varying. Neutral axis is not at the same location throughout the length. It will vary. Where will be the neutral axis here? At the center. Bending moment is 0. At the point of counterflexure, the bending moment is 0 and it is subjected to only compressive force. Where is the neutral axis?
Infinite.
Infinite. So neutral axis is actually not like this. Neutral axis is varying like this. And it will go outside and some very large distance. So as the moment will reduce, the neutral axis will change. So problem with neutral axis is that it does not remain at the same location in a column. In a beam there is no problem. Why? Because in beam you take bending moment about any axis, it will remain same because it is coupled. So there it does not change. Okay. So you can take theoretically neutral axis also as a reference axis, but there is problem. It will vary from section to section. It will not remain same for the member, and it will be known. It will not be known in the beginning. Okay. You will know it only when you calculate you perform the section analysis. You calculate the capacity of the section. That's the problem. So what is the natural axis? Suppose you are not doing anything. I am just asking you that make frame model of this. Actual frame is always having dimension, and I ask you to do. So what naturally comes to your mind? It comes that you take it at the center. So centroidal axis is a natural axis which comes to our mind. That's why without saying people use centroidal axis, without even making this very clear that we are taking centroidal axis. Okay, but it's good that this confusion came to your mind. Okay, so you understand. So generally we are teaching centroidal axis, we are calculating at the centroidal axis. You people take it for granted. Sir ने बोला तो centroidal axis पे करना. So you don't think about it, but a doubt comes that why centroidal axis? Then you have to think about it. Okay, so you can think that it is natural axis, but you can take any other axis as well, theoretically. Only thing is that analyst has to make it clear that about which axis the moment has been calculated, so that you can transform it to axis. Yes.
So in beam also moment is changing.
In beam also.
Moment is changing. Along
Yes. In beam also the moment is changing, and hence, so here the moment is very small, here the moment is larger, so maybe neutral axis is changing like this, or not, compression side it will be less. It may be something. Okay, but here it doesn't matter in case of beam because there is no axial force. So it doesn't matter about which axis. So when C is equal to T, you can take moment about this axis, you can take moment about this axis, or you can take moment about any axis here. The moment value will come out to be the same in case of couple. That is the property of the couple. So there you need not to bother that whether you are calculating about centroidal axis. Let analyst calculate about any section. Let designer do about any axis. Let designer take about any axis. Answers will be same. Problem occurs when we have axial force also. Then as the axial force is displaced, suppose there was only M will remain same if axial force was not there. Problem is coming because of this PE dash. Otherwise M dash is equal to M. Because P is there and it becomes important where you are considering P. So that's why in case of column this becomes an important issue, that about which axis we are taking the moment. Okay, it is so natural that centroidal axis we are considering that we usually do not think about it. Okay. But if somebody raises this issue, why centroidal axis? Why not neutral axis? Then you have to be clear that why we are taking centroidal axis. Okay. Now, one related problem which I was expecting from you to ask. Bending moment we have calculated about centroidal axis. We are plotting moment versus curvature. So moment is about centroidal axis. What about curvature? About which axis we have taken curvature? Neutral axis. So shouldn't moment and curvature be about the same axis? I am taking moment about some other axis, curvature about some other axis. Is it okay?
No, but curvature is telling the change in the slope.
Right.
So the change in the slope will be constant.
Constant means?
Means if the section, if you have the section and it is changing the slope, so one can easily measure this. We don't need to bother about it.
We not need to bother about it. Yes, anybody else? How we are calculating the curvature? This is neutral axis. Suppose I am thinking about centroidal axis. What would be the curvature? This, which is same. Okay? Because it is slow, it is independent of the axis. As long as strain distribution is linear. If strain distribution is not linear, then this will not be true. What is the condition for strain distribution to be linear? Plane sections remain plane. In which type of structures we will have that? Slender structure. So if I have a deep beam, okay, then things will change. Okay, and there the behavior cannot be represented by M phi curve. We have to represent it differently. Okay, shear also becomes important. So there we are not plotting M phi curve. Okay, M phi curve we are using for slender members, where the behavior can be represented by flexion, predominantly flexion. Shear can be neglected. And there you have plane sections remaining plane. That means curvature, if you calculate about neutral axis or you calculate about any other axis, curvature will be same. Okay? Any other question? Any other doubt in your mind?
Sir,
Yes.
while making PM inflection curve in column, if there is reinforcement and pure axial force is acting on this, no bending moment, the strain distribution is like this, like this, like this.
Yes.
Here we are limiting for column 0.002.
Right.
And corresponding in steel also we are considering strain 0.002.
Right.
That means at that stage the steel is not yielded.
Right.
And for that stress calculation is the steel, we are multiplying this strain into modulus of elasticity of steel. Okay. Sir is saying that this there is not valid here, that at this strain the steel is yielded, and here.
No, what sir is saying, forget.
Okay.
What you are saying, you tell me your this thing.
My thing is that here can we calculate this?
Somebody has said something. That may be sir, that may be anybody else.
Okay.
It brings some doubt to your mind.
हाँ.
ठीक है, जब दो लोग बोलेंगे, दो अलग अलग बातें बोलेंगे तो आपके दिमाग में डाउट आएगा, ये सही है, ये सही है.
हाँ, ये
How will
सही.
you decide in your life?
I have to say.
You have to think yourself.
Yes.
Okay. So think yourself and then tell me what is your doubt. There must be some doubt in your mind after this.
Doubt is that कि I have to calculate for calculation of stress. I have to multiply this 0.002 into modulus of elasticity, not yielding.
Not yielding.
Means stress should not be 0.87 F1 divided by EH. 0.87 F1.
But who is taking 0.87 F1? I couldn't get. Okay, how we are doing, let us say. I have a column section. It is subjected to pure axial force. Okay, so the strain distribution we take is this. Okay, our stress strain curve for concrete and for steel agree? And this is agree? After applying corrections and factor of safety. So these stress strain curves I have plotted after applying the size correction, size effect and friction effect. So 0.8 into 0.87 divided by factor of safety of 1.5. Here divided by factor of safety 1.15. So these are the stress strain. Now first question is, at what condition, what strain, I will say that limit state of collapse has been reached. What is limit state of collapse? That it is under imminent collapse. Okay. If I increase the load just a little bit, it should fail. So first question which should come to your mind is, why 0.002? Why not 0.0035? That should be the first question. Or somewhere in between. So why 0.002?
That I have clear, because here all the fibers are
Okay, if it is clear, clarify to others also, because I think others are having this doubt. Then why 0.002? And nobody is having doubt that why it is 0.002, then it is a sad situation. Okay. That means you are assuming whatever the teacher is saying. So in a way it is good that two teachers are teaching same thing. Okay. So then you should have some doubts. So it's not bad that you are having doubts. It is good that you are having doubts. If you are not having doubts, then there is problem. Okay. So why 0.002? Why not 0.0035?
Because in compression, all the fibers are subjected to equal strain,
Right.
to normal stress.
Right.
In case of bending, only top fiber is reaches to that maximum strain, and that remaining fiber, when the first fiber gets hit, remaining fiber will take into picture to get that value. So we are going up to ultimate in bending. In case of compression, we are going up to only that below value. Because
So at 0.002, your stress has reached the maximum, 0.446 FC. And if you increase the force a little bit, what will happen?
it will get fail because no cone is going to take.
The strain will, if you try to increase the stresses here, okay, it can't take. It will go on crushing, okay, and it will fail. Okay, so here you can take the stress diagram if you have to take. This stress diagram will be in concrete, 0.446. Now let us see what will happen to the steel. So at the same stress, same strain of 0.002, you have to calculate the stress, whatever it is. It may be 0.87 Fy. Okay. It may be less. Generally it will be less than 0.87 Fy. Why? Because 0.002 is the proof strain itself. Okay, so at 0.002, it can't reach this point. Okay, depending on the grade of the steel, the yield strain, you can calculate. Okay, so you will find it somewhere here. So you have to read from stress strain curve. You are not taking 0.87 Fy in that case. Okay, although if you take it close to 0.87 Fy, there won't be much error. It is close to 0.87. But actually, we should read from the stress strain curve that what is the stress here, and that stress we will be taking. That is already stress in steel.
Yes.
Okay, based on the modulus of plasticity of steel. So we need not to multiply it by anything else. No modular ratio or anything, because we have taken the actual stress in the steel. So now, what is your doubt?
That you have taken stress in steel equal to 0.002 into modulus of elasticity.
No, I have not taken. I could have said that, but I have intentionally drawn it that you have to read from the curve.
But that curve is taking values like linear from.
Let's do it. For Fe 500, let's take Fe 500. Okay, this exercise we have done in the last semester. What is stress in steel? Okay, at strain equal to 0.002. Let's see that. Is it ES into 0.002? No, it is not. So we never said that you have to take it ES into 0.002. It is not. We have how to calculate it. We did an exercise in the first semester, you remember?
Yes.
So you have to use that. Using that you have to calculate. And it is also not equal to 0.87 That is also not true.
we have interpolated those values in the
Yes.
Then
we have to interpolate it.
interpolated in
Right,
between.
right.
But that interpolated like 0.97 FY, that values come from here now, we multiply by ES.
No, it is not multiplied by ES. Multiplied by ES
Multiplied by ES
is only up to this point.
Up to 0.8.
Only up to epsilon. Okay, 0.8. This I have already written. So this will be equal to this strain here. This will be only equal to 0.8 into 0.87 Fy over ES. Only up to that you can take E into epsilon. Beyond that you can't take E into epsilon.
Okay. Let's take the strain that this is not 0.002. This is somewhere where it is going linear. Steel is going linear up to.
So you mean here? Here.
Stress corresponding to this.
Right.
This we have limited it here at the 0.002.
Suppose this strain was not 0.002, this was 0.001.
0.001.
Right.
Now I have to calculate, and in also steel there will be strain equal to 0.001.
Right.
Now how can I calculate stress in steel multiplied?
Then you can take simply steel stress as 0.01 into ES. Yes. So is there any problem there?
Now go to the strain diagram.
Yes, this is the
this
strain diagram.
strain diagram is uniform. Neutral axis is lying at infinity,
Right.
and if y multiply by this strain into stress, the neutral axis, the strain relationship is linear. This
You mean for steel?
no, for anything, if the strain relationship is like this, neutral axis somewhere lying here.
Right.
If the strain relationship is like this, that toward the uniform, neutral axis is somewhere infinity.
Right.
In this case, I can apply the elastic theory. That's stress into strain. Stress in
What is elastic theory?
Strain into modulus of elasticity equal to strain, like Hooke's law and all those things.
No, that you can apply only if the stress, first you have to ensure that stress in steel has to be like this. Elastic theory is not saying that if the strain diagram is linear you can apply stress theory, elastic theory. That's not the condition. Material has to follow the proportionality law. Then only you can apply elastic theory. So just because strain diagram will be always linear, whether you are doing limit state, working stress or ultimate flow, strain diagram will be always linear. Okay, strain diagram does not decide whether it is inelastic behavior or elastic behavior. Whether it is inelastic behavior or elastic behavior, that will depend upon the value of strain. If the value of strain is less than this, then it is elastic. Then you can apply working stress method or linear theory, whatever. Here you can't. You can't apply that. So you have to consider the act. First of all, you should assume rather some strain. At that strain, you should calculate stress in all the materials. Okay, and then calculate C and T. So that's what we are following. And we are taking actual stress at that given strain. So we need not to multiply by anything else. Okay. So your confusion is that because at 0.001 we can use elastic theory, so we can use it at 0.002 also, and then there is problem. Yes, if you are applying elastic theory at 0.002, it is wrong. It can't be applied. That's why error. Okay. At 0.002, steel is no more linear. Behavior of steel is no more linear. Okay. Any other doubt?
Sir, can you repeat y.002?
Why 0.002? Because if it has already reached 0.002, then this stress of 0.46 FCK has been reached. Suppose on this column I apply a little more load. What will happen? Concrete cannot take any more load. So concrete will go on deforming and it will finally collapse. So we cannot apply more than 0.002. Agree? I was expecting some doubt here.
it was clear, but I didn't get his doubt.
His doubt is that in case of axial compression, pure axial compression, why we are considering the strain at 0.002, not 0.0035. Am I right?
No.
That's his doubt.
That's
His doubt was different. You can live in without right, but those doubts are good. I mean, those doubts. See, if you are not having any doubt, doesn't mean you are wiser. Only a wiser person will have doubts. Okay, so not having doubt means you are a very good follower. Anybody will tell you anything and you will take yes, good. You are happy. So Babaji will tell you to go this direction, you will go in that direction. Okay, so that's not making you wise. Okay, doubts are very important. You should have doubts. You should have different types of doubts. So currently the question which we are examining is that is this 0.002 okay? Or it should be 0.0035 or any other value. So I told you that 0.002 is okay, all of you have agreed, very happy. Or there is anybody who is unhappy. I want to meet the unhappy soul.
So, you said that after reaching 0.002 the strain increases at same values.
The strain increases but the stress remains same.
Stress remains same.
Right.
So will it be bending?
Sorry?
Bending will have the same case.
No, there is no bending, it is pure axial force. So I have a column.
Bending we are taking 3.0.
But in bending we are taking 0.0035 when our first fiber ruptures. Whenever any one fiber ruptures, we are going till that point. There we are not stopping at 0.00. Okay, but in axial case, pure axial case, we are saying that you have to stop as soon as the strain reaches 0.002. You can't go up to 0.0035. Why? Why we are not going beyond that? Because if you apply little load, okay, more than this point, first of all, as far as the calculation of load is concerned, it is same whether you take 0.002 or 0.0035. Calculation is same. Okay. What will happen to steel? Concrete will crash. What about steel? Can steel take more load? Why not?
Area making that load is
Is that the answer? अभी तो हमने डिस्कस किया है एरिया जितना भी है मान लो मैंने खूब सारा स्टील डाल दिया तब at 0.002 steel has also yielded. Okay, it's very close. Just now we have seen even in Fe 500. Okay, it is very close to the yield point. So it has also almost yielded. So little more load will cause failure of concrete as well as failure of steel. So if you want to be very clear, you can, if you want to be very accurate, you can take this strain in place of 0.002. This strain will be slightly higher. But if you see the results, the capacity, it will be more or less. There will be very little difference in the capacity you are calculating.
why are we suddenly talking about increasing the stress in this 0.002? Like that can also be the case for moment.
See, what we are trying to do, why we are doing all this analysis? We want to calculate how much axial force my column can take. That's our objective. That's why we are doing all this strain distribution, assuming plane sections, remaining plane, everything. Okay, if this problem was not there, that I have to calculate how much axial force and bending moment my column can take, I was not worried about all this. So final objective is to calculate how much axial force my column can take. So I can go on increasing the axial force. Till when? It will fail. And when it will fail? When it reaches this is stress. And this stress will be reached at a strain of 0.002. So as soon as the strain will reach 0.002, If it is slightly less than 0.002, it will stop there. But if it is slightly more than 0.002, then what will happen? At that load, it will go on deforming. So 0.002 is giving us that limit state at which the maximum axial force is stable. If you increase load slightly more than this, it will go on deform. If it is less than it, it will be stable. So that load we have to determine at which the failure will take place, means that the deformation will continue to increase and finally it will either get crushed or it will rupture.
For moment.
Sorry? Moment. Yes. What happens in case of moment? So our stress diagram will be like this. Okay. If I increase the strain further, what will happen to the stress diagram? Can you plot? Can you think what is going to happen to the stress diagram? If the strain increases from 0.002 to let us say 0.003. What will happen to the stress diagram? The maximum stress will remain same because it has already reached. So I was going to increase it, but then suddenly I realized it can't increase. So will it remain same? No. The diagram will change like this. Till this is. Okay. So the C force is going to increase. And if steel also has that much capacity to increase, C equal to T. So the moment can still increase even when the strain in concrete has reached, okay, 0.002, still the section has capacity to take more bending moment, okay, because these fibers here, these are not strained to the full capacity. So there is still possibility to take higher moment. So there we can go up to higher strain. Yes.
In previous slide, and concrete block, we are stressed, and the upper limit of 0.002 strain value of project. And what is the physically happening in the concrete block in between 0.002 to 0.003?
Can you see when you are testing the strength, what is happening? So when you go on the cracking starts somewhere here, the micro cracks will develop, which will not be visible to you. Okay. And I also told you that actually this is not the real graph. This is also idealized. The real graph is something like this. That is another reason why we are not going in axial compression beyond 0.002, because beyond 0.002 actually the stress is decreasing. It even doesn't remain same, it decreases. Okay, so as soon as you will reach 0.002 axial compression, it will come. Now what is happening, suppose it is concrete, if you visualize that, what is happening in concrete? Here at this point, micro cracks will develop. Okay, these micro cracks will progress, will increase. They will start being visible. When it reaches here, then cracks will appear. And then here, it will stop. Okay. Yes.
In case of idealized graph, we are considering strain up to 0.0, and corresponding to the steel, we are also considering 0.002. If the steel is
Sorry, can you repeat in idealized stress strain diagram for concrete, we are considering strain up to 0.0035. Oh, pure compression. So strain diagram we are not considering. Strain diagram is up to 0.0035. Idealized strain diagram is 0.0035. We are permitting strain up to 0.0035.
And same strain we are considering into steel also.
Yes.
In case of Fe 500, it is ED. But if there is a case where the steel is have higher grade, then suppose it is it is in elastic state only. Then we can go for.
That's why I said that if you want to be very accurate, okay, but keep in mind that the strain is, let us say, here, at which your steel is yielding. Suppose you are taking this strain in concrete also, then consider this reduction also. The increase in steel should be more than reduction in this concrete. Then only you can take higher. Okay? But first of all, more than Fe 500, steel is not allowed. 550 to be more precise. More than 550 steel is not allowed. And this reduction in concrete will be much more than the increase you will get in steel. Why? Because he said area. Area of concrete is much larger. So reduction in concrete will be much larger than the gain you are having because of the steel. So that's why the court says, consider this, there is no point in doing calculations beyond this point.
सर
Yes.
जो हम सेक्शन एनालिसिस कर रहे हैं उससे हम कैपेसिटी निकालते हैं
Right.
और कैपेसिटी हम दो मटेरियल लिए दोनों मटेरियल से जो वीक है वो गवर्न करने का लाइक कॉन्क्रीट
नहीं,
हाँ
दोनों की उस स्ट्रेन लेवल पर अपनी अपनी स्ट्रेंथ होगी.
हाँ, अपनी
we
अपनी-
will take that.
हाँ वी विल टेक दैट
इसका छोटा कंट्रीब्यूशन है, उसका छोटा कंट्रीब्यूशन ले लेंगे, इसका ज़्यादा कंट्रीब्यूशन का ज़्यादा कंट्रीब्यूशन ले लेंगे.
नहीं
गवर्न करेगा स्ट्रेन लेवल,
हाँ स्ट्रेन लेवल
whichever is reaching its collapse strain first.
फर्स्ट
Okay, failure strain first. That will be our cutoff point. That is our limit state. So if concrete is reaching 0.0035, that is our cutoff. If steel is reaching how much? 14.5% in monotonic load and 5% in cyclic. That is our cutoff. Okay. So cutoff is not decided by strength. Cutoff is decided by the maximum strain that member can take. Sorry, that material can take.
What does mean by cutoff?
Cutoff means limit state. Where you will be doing your calculations. So what is the limit state? Where you are calculating the capacity. Okay. So somewhat clearer or more confusing?
No, sir. Good.
Yes. Yes.
So in this table, it is given that we need to calculate the balance.
Right.
Okay. So the balance condition is for the machine, it should be 0.0, but the cycle is 20% constant.
Right.
In the limit state.
Right.
But we are assuming a concrete that is in the confined state. So is it any difference
No. Flow balance is calculated like
as
that.
per the ISO?
This is conventional flow balance which we are doing in our calculation.
As per IS 456. But we are using this, so I didn't get anything. What is it taking? AC 41.
AC 41 for row balance is referring to ACI 318. ACI 318 is equal to our IS 456.
Almost.
So row balance is the same which is given in IS 456. Yes.
For column, we are using PM reduction.
Right.
So in case of if there is such a condition which is the first in the access, so why don't we consider P versus K in the existing fiber of the column?
E versus
Strain line.
E versus strain line.
Because
how you will
ultimately from moment, sir,
So analysis can give you moment. Okay. So you have to design for combination of P and L.
limit that P in strain line, because ultimately moment will create a strain at the section. So we can limit the strains.
We are doing that. We are limiting the strain already. Okay. We are limiting the strain. But finally we need to calculate M na, because we will be able to compare M only.
So if we are limiting strain, then you can consider moment from any axis.
No?
Because
No, that's not the problem we were discussing here, no? Strain diagram remains same. Strain diagram is same. Let us say 0.0035 here, and here some epsilon st greater than 0.002 plus fy over here. Okay. So strain is fixed, but with the same strain, if you calculate moment about different axes, the moment will be different. So giving a strain diagram doesn't solve this problem of sac axis. Okay. And there is no confusion about the axis.
so
We now, there should not be any confusion, but if there is any confusion related to axis, you should discuss that.
I'm saying that if the strain is fixed,
Mhm.
so if you change the neutral axis for moment calculation anywhere, your moment will change according to your strain.
Right.
If we increase the axis further away, then your moment will reduce.
Right.
Because strain is limited.
Right.
So why don't we use P versus the strain interaction diagram? P versus M interaction diagram by if
Because for the same strain, because first of all there are two strains. One is here, another is here. So which one you will fix?
So we will confine that this compressive strain.
So 0.0035. So at 0.0035 also for different depths of neutral axis, there are different strains here. Okay, you will get different moment capacity. So one strain of 0.0035 under different axial forces will give us different moment capacity.
For single axial force it will be same. So we will get a graph like the interaction diagram. So we can use that also.
Yeah, but there the depth of neutral axis, if you are calculating just P alone, okay, you are not giving M. How you will obtain the depth of the neutral axis? Because strain, okay, and depth of the neutral axis, that together will decide. So you have to perform analysis. Just giving P and strain 0.0035 does not give you moment directly.
So but we can consider moment about any axis. It will be adjusted according to the strain.
So you have to adjust it now. That's what I am saying. You can adjust now also. Okay, you have calculated your PM interaction curve. Here, M is about centroidal axis. Suppose you want to compute it about the face here. You can do it. You have to simply adjust it. But if you want to do it about neutral axis, then there is a problem because neutral axis will not remain same. Neutral axis is changing. So neutral axis is particularly problematic for considering as the reference axis. Okay, any other doubt? Yes.
In ASA 41, when we have checked for the shear, we divide into post that we have using for the sections here, we have calculated the section applied moment.
Here is the applied shear.
Applied shear.
Moment means on any section there are three
From the
actions available: P and P and N are same. P, M and V. So these are the applied actions. So axial force, bending moment and shear. So these you will get from analysis. And that you will use for determining the response of the section of man. For the column with cross section, for the yield surface. Yield surface is PM interaction, right? So this is E and this is My. How do we define My?
Movement about y-axis.
Not moment about y-axis, this is yield moment. So yield surface means the plot of axial force versus yield moment. So yield moment depends on axial force. So how to calculate yield moment? Actually yield moment is coming from the M5 curve, and you do equivalent bilinearization, then this value is My. So how to plot PMY? Every time you have to plot a PM reflection curve at different axial force. Okay, it will be interesting. Can you these are the 3 points on PM interaction curve. Can you plot the qualitative M5 curve corresponding to these 3 conditions? One is P equal to 0. Second case, P is less than P balance, and P is greater than P balance. Can you plot the M5 curve? How it will look like? Everybody is trying. The qualitative M5 curve. Suppose you do an analysis. Okay, Tajul has already taught you how to draw the cross section in section designer and plot M5 curve. Suppose you try M5 curve at these 3 points. What you are expecting? How the curves will look like? So simple. You have to think about stiffness, whether the stiffness in the 3 cases will be same. Then you have to think about strength, and then you have to think about ductility. So these 3 parameters should be reflected in your plot. Is the stiffness same in the 3 cases? Stiffness is what? Slope of M5 diagram. So is the stiffness, slope of M5 or effective EI same in the 3 cases? No. So your slope of M5 curve can't be same. Is the strength same? No. So peak will be different. Is the ductility same? No. So the ultimate point will also be different. So when you are plotting the qualitative curve, these 3 parameters, the change in stiffness, change in the peak value, and change in the ductility should be visible. It should be reflected. So you are clear about stiffness and strength. Stiffness is increasing with action. You know that. Okay. So stiffness in 2 will be more than 1, and stiffness in 3 will be more than 2. Stiffness will be increasing with action. Strength, you can see from here, From 1 to 2 it will increase and 3 it will reduce. What about ductility?
The strength is increasing and ductility will reduce.
The strength is increasing, the ductility will reduce. Okay.
On an average, on a number will increase.
What about 1 and 3? The strength is more or less same. What about ductility? What happens to ductility? You have done an exercise for steel. Count. What happens to ductility when axial force is there? You can also think it like this. What happens to the neutral axis? When and if neutral axis is coming to downward, what will happen to phi? Phi is EC over epsilon C over XU. So if XU is increasing, epsilon C remains same, 0.0035 or whatever. Okay, so it is going to decrease. So ductility decreases with axial force. The stiffness increases, strength increases and that decreases, and ductility decreases. Now you count. I have given you enough clue. Okay, so you try, discuss, think. I don't know whether it is available anywhere or not. So I can't say that whether you can get it from reading or not. But you can think and discuss, and we will discuss when we meet tomorrow at 4.